You'll notice that I'm skipping over the virtual basketball league problem. This is one we solve with a diagram, but you can also solve it with a systematic list, so it's great to read over so you can see an alternative approach. But I'm going to look at pennies, dimes, part one. Clearly, these folks have hit hard times. This is what's going to happen if this coronavirus keeps going for us, or we're all going to be worried about quarters and dimes. Oh, good Lord. Please do not let this happen. Okay, so it says Nick's daughter Penny has 25 dimes. She likes to arrange them into 3 piles, putting an odd number of dimes into each pile. And how many ways could she do this? Meaning, in how many ways could she put an odd number of dimes into each pile? So you're looking at different combinations of odd numbers in these piles. Okay, so we're going to just label a table. Again, pile 1, pile 2, pile 3. We're going to use that idea of freezing to help us keep a systematic list. So honing in on the idea of odd numbers. So she has these 25 dimes. We could put 1 in pile 1, 1 in pile 2, 23 in pile 3. We could put 1. We're going to jump up to the next odd number above 1, 3 in pile 2, and that would allow us to put 21 in pile 3. We could put 1 in pile 2, jump up 2 more, put 5 in pile 2, jump down 2 in pile 3 for 19, 1 in pile 1, jump up 2 in pile 2, 7, jump down 2 to 17 for pile 3, 1 for pile 1, 9 for pile 2, 15 for pile 3, 1 for pile 1, 11 for pile 2, 13 for pile 3, 1 for pile 1. Notice what happens here. We would come up to 13, down to 11 here. This is a repeat of what is happening in terms of the odd numbers in each pile. These would be considered the same. So that means we've exhausted all the possibilities using 1. So that idea of freezing is extremely helpful with determining if you've exhausted all possibilities of a given number. So now let's jump up to 3 here and see what happens. We can do 3. We could do another 3 here and 19 here. Once you get started with an initial combination, then you can apply that same strategy of freezing the first one, jumping up by 2, and jumping down by 2. So 3, 7, 15, 3, 9, 11, and then 3, 7, or excuse me, 3, 11. Let me see what I did. Oh, I made a mistake up above. This should be a 13, and then we would have 3, 11, 11. And then when we go to write 3, 13, and 9, we see a repeat. So we've exhausted everything, and we need to cross this out, and that means now that we will jump up to combinations where we have a 5, and we'll freeze that. So we do 5, 5, 15, 5, 7, 13, 5, 9, 11. But when we hit this one, we get 5, 11, 9. And again, these are the same. So we'll stop with our 5s and move up to 7. So then we have 7. You can do 7, 11, 7, 9, 9. But when we try the next combination, we get a repeat here again. These are the same, so we could cross this out. And now we could try 9, 9, 11, 5. But we have this combination in another place in our chart, right up here. So it's the same as those others, meaning it's going to repeat. We've exhausted everything, because if we start to go up then and try 11 again, we're going to see that we have all the 11s that are in here, and we would see a repeat. So that idea of freezing is really, really helpful. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different possibilities. A couple trends that you'll notice. That second pile must be equal to or greater than the first. So this second pile has to be equal to or always greater than the first. And that third pile must be equal to or greater than that second pile. Because when those trends or traits are not happening, that's when you get the repeats. So those are some things you want to point out when you're establishing a list, because those trends really help you enhance your problem-solving skills.